Students, this question was asked in the year 2000 from the chapter Oscillations in NEET exam. The bob of a simple pendulum having length L is displaced from mean position to an angular position theta with respect to vertical. It is released the velocity of bob at equilibrium position. Okay, student, let us consider this case by drawing. Okay, drawing the diagram. Suppose from this point the pendulum is hung, this is the thread, and suppose this is the bob, student. Okay, this is the bob, and the pendulum having length L. This is, student, this, suppose let us write this as A, this is B, and it is displaced from mean position to an angle position theta with respect to vertical. This is the vertical, and suppose, student, this is displaced through an angle theta. This is theta, student. So this is also L, and this is suppose L, and let us name this point as C, and we will draw a perpendicular on AB from the point C. And suppose, student, this is the point D. Okay, student, this is the suppose the point D. Then what will be BD, student? BD will be equal to AB minus AD. Okay, student, what is AB? AB is L. And what is AD? Student, look, this is theta. So AD by L is cos theta. Okay, student, AD by L is cos theta. So what is AD? AD will be equal to L cos theta. So we will write here L cos theta, or this is L. If we take common, this will be L within bracket 1 minus cos theta. This height BT. Okay, student. And you know, student, when the bob of a simple pendulum executes simple harmonic motion, this is the extreme position. Okay, student, this is the extreme position where it reaches its amplitude, and at this position the velocity of the bob becomes zero. Students, what is the energy of a simple pendulum? The energy of a simple pendulum, the total mechanical energy is denoted by E, and that is the sum of the kinetic energy and the potential energy, student. At this point C, you see, student, this point C is at h height above the point B. Okay, student, this is the point B. So this is the point C is h height above the point B, and at point C, the displacement of the bob of the simple pendulum is maximum, and this distance C is called the amplitude, student. And here the velocity at this extreme position of the simple pendulum's bob becomes zero, and the entire energy becomes its potential energy. And what is that? What is potential energy? That is V is equal to mgh, where h is this distance, BD. Okay, student. And because V is 0 here, what is the kinetic energy? E is equal to half mv square, student. And because V is 0, the total kinetic energy here is 0, and so the total mechanical energy is T plus V, that is only mgh. Okay, student. And at this point B, what happens? The reverse thing happens. Here the velocity is maximum, student, and the position vector is here. So the height is here 0, because this is the point of reference, the mean position. So here the height is 0, and the potential energy is 0, and the entire energy is kinetic. So, student, at this point, half mv square will be equal to mg h. Okay, student. Then mm cancels out, and what will be v square? V square will be equal to 2gh, or v will be equal to root over 2gh. And what is h, student? We have already found h. H is this distance. BD, what is that? BD is equal to L into 1 minus cos theta. So, student, the velocity of bob at equilibrium position B will be root over 2g L into 1 minus cos theta. That is in option A. So option A will be the correct option for this question, students.